Hey, chemist and biochemist, I wanted to talk to you today about maybe the two, let's say, most important kinetic parameters for any enzyme. Now, those kinetic parameters are your Km and your Vmax. Okay, so I think that the Vmax is a little bit self-explanatory. The Vmax is the maximum velocity of an enzyme. Now, to dig a little bit deeper into that, well, when you think about the velocity, or whenever you think about velocity, you should think about a rate. And so, really, what we're getting at here is the maximum rate of product generation. So, max rate of product generation. Okay, our other kinetic parameter, I would say it's a little bit, it's not quite as direct. Now, with that said, though, it's something that you can actually kind of understand from a couple of different angles. Well, for starters, the Km is the amount or concentration of substrate required to reach 1/2 Vmax, which I'll go ahead and say, or Vmax over 2. I think that the best way and the easiest way to understand these two kinetic parameters, and the reason that I always like to think about them kind of together, is I like to look at a Michaelis-Menten plot. Now, the Michaelis-Menten plot has a y-axis of initial velocity versus an x-axis of substrate concentration. Now, generally, an enzyme is going to, or if an enzyme follows Michaelis-Menten kinetics, it's going to generate a plot that looks a little bit like this. Okay, so what you can see here is on the y-axis, or if you relate the y and the x-axis to one another, you can see that as your substrate concentration increases, so moves, as you move in this graph from the left to the right, so from the origin right here to this side right here, where I just put an infinity or a star, as your substrate concentration increases, what happens to the data on your y-axis? Well, that goes up. Now it goes up, but it doesn't go up in a linear fashion. What you're going to see in addition to it not going up in a linear fashion is at some point, and I'm going to go ahead and highlight it basically here to here, is as your substrate concentration continues to go up, what happens to your velocity, your initial velocity? It basically it flattens out, it plateaus. So this is where no matter how much additional substrate that you add to this reaction mixture, your velocity is not going to increase. And so you can use this Michaelis-Menten plot to estimate your Vmax. So your Vmax is going to be like that. Now, what you can do with this is basically say, okay, well, what is half of that along my y-axis? It's right there. Okay. Now, how does that coordinate to my x-axis? Just like this. Okay. Now, what that's going to give you is that's going to give you an approximation as to your Km. Now, things to consider with respect to your Vmax and your Km. I always like to think about units. Well, your Vmax is the rate of product generation. So what you have there is product generation, which is going to be measured in something like molarity per unit time. So something like seconds. So micromolar per second are possible units for Vmax or velocity in general. Km, on the other hand, where is Km? Km is along your x-axis. Therefore, Km is going to be a concentration. So something like molar, nanomolar, any number of other things. These two kinetic parameters are, I would say, the first two that you're going to get anytime you analyze an enzyme. And they give you a little bit of information about kind of the capacity or the limitations and the boundaries at which an enzyme is going to be able to perform at. So how fast can it go, and how much do you need to provide that enzyme with? How much substrate do you need to provide that enzyme with in order to get it to go that fast? All right. Well, I hope this was helpful. Have a good one.